welcome back to Solve with Danny, and we are going to be practicing today finding lengths when we're given secant lines with tangent lines and sometimes some intersecting chords within a circle. And then we'll get into some more algebraic examples as the practice problems commence. So this is great review for your test, your unit test, or for your Regents exam if you're in New York State. All right, so when we have our tangent line in a secant line, we're going to do the tangent line squared equals the outside part of that secant, which in this diagram is 9, times the length of that whole secant line, 9 plus x. And then we're going to solve. So we get 225 equals 81 plus 9x, subtract 81, we get 144 equals 9x, divide by 9, and we get 16. So the hardest part of this is just knowing the setup right here. If I can highlight it, right there. Tangent squared line equals the outer part of the secant times the whole secant line length. All right, so let's try another example. This one, we have 2 secant lines. So it doesn't really matter which line we start with, but we are always going to start with the outside part of the line. So in this case, we have 3 times the length of that whole secant line, which is 8. You can really write 3 plus 5 if that makes you happy. It does not make me happy. And then we have the other outside part, which is 4 times the length of its whole part, 4 plus x. All right, and now let the solving commence. 3 times 8 is 24. Distribute. You get 16 plus 4x. Now it's just a little bit of algebra here. So we get x equals 2. Not too shabby. Not too shabby. All right, let's get into a little bit more of an algebraic example because now we've got that binomial. So be careful. Okay, parentheses are our friend in this case. All right. So we've got the outer part of that secant, which is 4, times the whole length of it, which this one I will write it out. And then we have the outside of the other one, which is 5, and then its whole shebang as well. And then we're going to simplify inside those quantities. So we've got x plus 1. And in the other quantity, x minus 1. So you could really go right into, like if you really wanted to, you could just straight up write that step. To each their own, whatever works for you. And now we are going to solve away. So let's do some distributing. If you need some equation practice, check out my algebra playlist. That'll hook you up pretty good with equation solving. So we distribute 4x plus 4 equals 5x minus 5. Now we are going to solve. So for me, I love to avoid minus signs, negatives. So I'm going to add the 5 over, but you could subtract the 4 over to start if that's what you wanted to do. We'll get to the same place in the end, so it's okay. But for me, if I can avoid it on the front part, I will all day. We get 9 equals x. So if we really wanted to, just for fun, state the length of this, x minus 3, that would be like 9 minus 3, which equals 6. And then we have 9 minus 6 here, which equals 3. Technically, we just needed to solve for x, but it doesn't hurt to check to make sure, does my answer make sense? Because if you got a negative there, then you know you did something wrong, okay? So it doesn't hurt to check just a little bit. All right, we have a tangent and a secant line. So I like to start with my tangent line, which is 6 squared. And the reason it's 6 squared is because it's the outside times the whole. Well, the whole and the outside are the same with the tangent line. So that's the 6 squared. And then for that secant, we have 4, the outside part, times the length of the entire thing, 4 plus x. And now just a little bit of algebra. Let's go. Whoop. Moving my page here. So 16 plus 4x. We subtract 16 from each side. Divide by 4. Bing, bing, boom. We get 5 as our answer. Not too bad. All right, let's get into some chords. So with this, it is going to be, and this goes back to similar triangles, so refer back to your notes. Or if you really want me to do the proof, comment below, and I will do a lesson on the proof for all of these. I just figured a lot of you are just like, get to the example, lady. So here we are. Get into it. So with chords intersecting inside a circle, we like to do the piece times the piece. So 9 times 4x. And then the other piece times the other piece. So I'm just color coordinating that a little bit for you. So you have the 2 pieces of the first chord being multiplied by each other equals the 2 pieces of the other chord being multiplied by each other. And then algebra land, we solve. All right. So we get 36x equals 32x plus 16. Get all our x's to one side. So we get 4x equals 16. So we get a pretty little answer of x equals 4. It's always nice when they work out to be pretty numbers. You might get decimals sometimes. Don't panic. It's okay. Just see, does your answer make sense? All right, next problem. 2 chords again. So we have the first chord being multiplied, its pieces. And then the other chord, its pieces being multiplied. So we get 4x equals 40. Maybe I should have started with that one. A little nicer. For the solving piece, we get x equals 10. X equals 10. So I hope these couple practice problems cleared it up. If you would like another part where I do some more examples, because I definitely have more made in my repertoire, we can go forth and do them. But it's just making sure you've got those equations set up correctly. And then it's just algebra, baby, which you already passed because you made it to geometry. So congratulations, friend. All right. So I hope you hate math just a little bit less. Be careful with those parentheses. If you need to see more or want to see more, comment. I am so open to making more videos based on your needs. And I hope you hate math just a little bit less today. Have a great day, everybody. Make sure you subscribe.